In this lecture, we will discuss a little bit about more regarding with the IP addresses. So, uh, basically, the IP address consisting of four parts, and each part is separated with the help of a dot, and which where is my cursor pointer? Okay. So, IP address is consisting of four parts, and each part is combined with the help of 8 bits together. And if you combine the 8 bits together, so that becomes 1 byte. So we have a 4 octet available when working with the IP addressing, and the range of each octets is starting from 0 and end with the 255. It means if you see a more than 255 number in any of our octets, so it means that is not a true IP addressing, and that is a one of example of IP address. There is a no more than 255 number available here. Okay, so discussing the IP addresses separated with the dots, and we have a 4 parts working if we are working with the IP addresses. So this is a one of a way of understanding the IP addresses, and this is a one of IP version 4 addressing suite. It's a dotted decimal notation format, and each octet must not exceed from the number 255. There's a logic behind that thing. We have a starting from a 0 and ending with the number 255. No word, no digit is available here which exceeds the number 255. You have 254, you have a 1 is here, 16, 172, and not more than 255. You see a more than 255 number in any of our octets, so it means that is not a true IP version 4 addressing scheme, and that is a decimal notation here, and this one is a binary notation. We will learn how to convert the decimal number system into a binary number system. So this is just one of our representation of your decimal number system. So it's again telling us one idea. If you combine the 8 bits together, so that becomes a 1 byte, and if you're combining all the bits, so it's become a 4 byte IP addressing version 4 addressing scheme. So if you count these binary numbers here, so that's is a 32 bit number addressing scheme, which is a IP version 4 addressing scheme. So again, talking about a little bit the domain name as a text version of IP addresses, as we discussed earlier, and the DNS server is a one of a server which translate the domain name into a associated IP addresses. So we have a one of a server which performing this type of operation, the conversion. So the conversion process from the IP towards the domain name, so we need a one of a special server required, and this special server is called a DNS server. So this is a domain name, one of example of your domain name, www.google.com, and behind this thing you have a one of associated IP addresses. And this is again a one of example of a domain name addressing. This is one of your website, nto/fcs/fcs irmsc.php. So a computer, it's tell us one idea. A computer connecting with the internet is assessing the academic resources of a NTO. And what type of academic resources they are assessing? They are assessing the FCS academic resources here. So, and this is a one of education institute hosted inside of Pakistan. This PK is representing this thing. This website is hosted inside of Pakistan, this edu representing it's the education institute. FCS is a one of a folder or directory, and inside the FCS you are accessing one of a particular resources here. So this is a very good example when understanding the domain name addressing. And there is a one of a command here which is called a ping command, used to find the IP addresses behind the domain name address. If you write the ndu edu pk, so if you ping the ndu edu pk, so after the ping command you see this type of IP address is available in front of you, and that can be done in a CMD command based version of a Windows. If you go into a CMD version of a Windows operating system and write the ping space ndu edu pk, so you see this type of addressing is available, and no computer on the internet have a same IP address or a domain name addressing. So IP address is decomposed into a 4 portion, and each portion representing with the help of 8 bits, and 4 portions can be further divided into 2 categories. So we have basically a network portion and a host portion. A network portion is representing one of a network. For example, if you are running the NTU network, so that is one of a network portion in IP addresses, and inside a network you are accessing one of a targeted server, or you are accessing some of a person inside the NDO. So basically you are accessing one of a host, so I have a host portion also available inside the IP addressing scheme. So basically we have 2 things available when working with the IP version 4 addressing scheme. We have a network address, and inside a network you have a client or a host address or a server address. So here is one of example. You have a 3 classes available when working with the IP version 4 addressing. In class A you have a 255 bits associated for a network, and the remaining are associated for the host. It means that your class A IP address is consisting of one network portion and 3 host portion. If you move towards a class B, so you have a 2 network portion available and 2 host portion available, and if you go towards the class C IP addresses, so you have a 3 network portion available and 1 host portion available here. And this is the number of hosts available in a class C. It means you can accommodate 255 hosts if you are working with the one class C IP addresses. And if the starting, this is a very important idea here, if the starting of IP addresses from 1 to 126, it means this is a class A IP addressing scheme. If you see a number from 1 to 126 here in a very starting of IP address, so you can identify that it is a class A IP addresses. And if the number is ranging from 128 to 191, so it means it's a class B IP address. And if ranges from 192 to 223, so it means that is a class C IP address, and that is a very starting of each IP address. This is a starting numbers. I am talking about the starting numbers only. Okay, the class C is let's see one of example here. If I need 50, I'm running one of a company working with 50 clients, so what type of IP addresses suits me? So that is one of our problem here. And for 50 clients, so class C is going to be very good, because in one IP address of a class C you can accommodate 255 hosts. But if I'm running the one of a company which consisting of more than 255 hosts, or more than 255 clients, for example, I have 500 clients working in my organization, so I have to shift towards a class B IP addresses, because inside a class C, what is the maximum host possibility option is 255. So if I have more clients, so I have moves towards the class B, and if I have more client here in a class B, so I have to shift towards a class A IP addresses. So it's again working with the IP version 4 addressing. It's a combination of a 4 IP addresses parts provided 4.2 billion possible addresses. So if we combine all the IP addresses together, so it becomes a 4.2 billion possible addresses, and that is one of example here. Each octet is not exceeding from 255 starting from 0, so that becomes a 256, and if you multiply these together, so that is a total number of IP addresses available when working with the IP version 4 addressing scheme. So it's representing a one idea here. You cannot go beyond 4.2 billion possible addresses, but that is a huge number. If you look at the devices before the 1998, so that becomes a huge number to connect the number of devices with the internet, to identify the devices in the internet. So this is IP version 4 addressing is very good. But nowadays, look at here, even you can use 5 to 6 IP addresses. Look at your example of your home. So inside your home you have one of a cell phone, so working with the internet, so we need one IP address for our cell phone. Sometimes you have a 2 cell phones available, and we have a desktop computer also available. We have a IP TV is also available. So you have other devices also available which run on the IP addresses. So yeah, only a single person can take 5 to 6 IP addresses. So nowadays we need some other solution, because that is not the possible option when working with the IP version 4 addressing scheme. So 4.2 billion is good up till 1998. After that time we move towards a more IP addresses devices, so we need more IP addresses to so resolve this problem. So we have to scientists working on this level, and they resolve this problem. They come up with a solution that we need another type of addressing scheme, and that addressing scheme is called IP version 6 addressing scheme. So this is the IP version 6 addressing scheme we are working with nowadays. IP version 4 is still working here, and that is one of a comparison in the two classes. So IP version 4 address is a 32-bit address, and working with the IP version 6 addressing scheme is a 128 bit number. And similarly, if you see the representation, that is a dotted decimal notation when working with the IP version 4 addressing scheme, and when working with the IP version 6 addressing scheme, we have a hexadecimal notation. You have a alphabet is also coming with the numbers, so we have a hexadecimal representation of your IP version 6 addressing scheme. And prefixes are one way of representing the subnet mark, so you don't going to be confused at that level. That is a very basic level, so I'm not going into the depth of this thing. So and the number of addresses when working with the IP version 4 address is at 4.2 billion, as we discussed earlier. If you go to the 2 is about 32. Why 32? Because we have a 32-bit number here. So working with 2, because we are working in a binary number system, so 2 is about 32, that becomes a 4.2 billion possible IP addresses. And when working with the IP version 6 addressing scheme, as the 2 is about 1 to 8, it means you have a huge number here. Look at this thing, that is a not a countable number, so it's a huge number. When working with the IP version 6 addressing scheme, you can accommodate these devices. Oh, it's a huge number then. So that is the thing why nowadays most of the clients and most of the servers are shifted towards the IP version 6 addressing scheme, because IP version 4 is no more available. And here is the one of example of IP version 6 addressing. There we have a 4 bits number, and we have a 1 2 3 4 5 6 7 8 4-bit numbers available, separated with these representations. So This is a one of example of a IP version 6 addressing scheme. So at the end of this chapter, we'll discuss a little bit about the internet tips and tricks. So if you have a if you write a plus before the word or in front of a word, so you give the importance, and that is how I'm talking about when you are surfing something on the web browser, and we want to give the importance of one of a particular word. So if you write a positive symbol before the word, so it's going to be the browser software give the more importance to that word. They find out more result resembled with that particular word. And similarly, if you write a minus sign in front of any word, so it's give the browser software gives a less importance to that particular word. Similarly, if you want to find the one of line, so we have to use these type of quotation marks. If you write anything in these quotation marks, we have example here by MS American, so the browser come up with this type of result. What's happened when you search something, the browser software look each word separately. They search each word separately. If I not use these quotations, so bye is one word, then you have a miss is another word, American is another word. But if you use these quotations marks, so it's search as it is. And then this is one of example here. If you write a positive here in front of a hybrid, so hybrid word is going to be important for a web browser, and they give a less importance to these three words. Similarly, if you write a lowercase, so it's find out both the lower and upper cases version. But if you write the uppercase only, so it's go for uppercase results only. For you have an example here. If you write the president in the uppercase, so it's only search that particular uppercase words available on our web pages. But if you write the president in a lower cases, so it will search both of them, the lower and upper cases. Control F is one of a command used to find anything in a web browser pages, web pages. So Control F is one of a short key, and then you have another short key available, Control plus Shift plus T, and that is used to open your last close tabs on a web browser. That is a very good key, and I also using this key frequently, because so if you have a power failure or anything, you just unfortunately close your pages and you want it back, so just use this short key, and this will give you your closed page back. So, and if you want to find some of PPT presentation, so we have to use these type of things. .ppt is one of extension. .pdf is one of extension for the PDF file. .exe is used for executable file. So if you write to find the PDF of one of a document, so you write that document name, and then after the document name you write this thing. So the results will appear according to the PDF formats. So that is the end of your chapter 2 from your book Discovering Computer, and that is the internet and our World Wide Web. Thank you.